Hey folks, welcome to this episode on molecular formulas where we're going to be doing a different example of calculating or deducing our molecular formula. So let's take a look at the question that we're given to today. It says a 13.8 gram sample contains only nitrogen and hydrogen. This is a big key. When it's heated, it's decomposed and it produces 4.2 grams of nitrogen. Knowing that the molar mass of the original sample was 92.02 grams per mole, determine its molecular formula. All right, so what are we dealing with here? Normally, when we're dealing with empirical or molecular formulas, we are going to be given percentages that we have to turn into grams, or sometimes we're even given the grams. Here, we're not given the grams of everything. We are given the grams of our original sample and then what it produced in nitrogen. But we do know one thing. First of all, let's break down this formula and see what's actually going on. So we have some kind of sample that contains both nitrogen and oxygen. We don't know what these subscripts are. This is going to be our goal. And when it's heated, we're going to put a little triangle for heat. It breaks up into nitrogen. So we know that this is diatomic. This is going to be a gas. And we know that it's also going to break up into oxygen because it's decomposing. Okay, what we are given is that our original sample was 13.8 grams and it produced 4.2 grams of nitrogen. Now, in order to figure out our nitrogen, we also need to figure out our oxygen so that we can figure out the subscripts and the ratio of those two elements together within this original formula. So we need to know this. Now, remember, there is that wonderful law called the law of conservation of mass, meaning that mass cannot be created nor destroyed, it's conserved. And so if our original sample weighed 13.8 grams and 4.2 grams of nitrogen was produced, we can use this law to determine how much oxygen is also produced. So all we have to do is take our original mass, 13.8 grams, and subtract the amount of nitrogen produced. And what we can do is we can find that 9.6 grams of oxygen was also produced. Now we have the amount of oxygen that was originally in our equation and the amount of nitrogen that was originally in our equation, right? Because we can't produce any more from what we had. So this is how much we originally have. Now what we can do is we can use these values to calculate our empirical and our molecular formula. Now, we don't need percentages because we already have grams. Remember that if we are given percentages, the first step is to assume 100 grams of a sample so that we can convert those percentages into grams, but we already have those grams. So let's just start there. First of all, we're going to break up our elements. We have nitrogen and we have oxygen, and we have 4.2 grams of nitrogen and 9.6 grams of oxygen. Now, you might be thinking, hey, we have 4.2 grams of N2 and 9.6 grams of O2. Why are we using it for these ones? But remember that in order to produce this, it had to have come from what we had originally. So we already had 4.2 grams of nitrogen in our original compound, and we had 9.6 grams in our original compound. So that's what we're using. So once we get things into grams, the next step is to convert this into moles. So we need our molar mass of nitrogen, and we need our molar mass of oxygen. Again, we are not using the molar mass of the oxygen that is produced or the molar mass of nitrogen produced because those are diatomic. We are looking for the original formula, which is why we're only using the molar mass of a single atom. So in these cases, our grams will cancel out and we'll be left with moles. And so let's see how many moles we got. So if we calculate this through, we will get 0.299785 mole of nitrogen. And here we will get 0.6 mole of oxygen. So now here we find our lowest mole value, which is the first one, 0.2, and we're going to divide both of these values by that number. So 0.299785 mole, and we're going to do the same thing for this one. Again, our moles will cancel out, and we will get left with a unitless number. Now, this one is an easy calculation. This will be exactly 1. And here we will get 2.001426, which we can round to 2. Awesome. We have our subscripts for our empirical formula. So our empirical formula is going to be NO2. But remember, we never really write the ones, so it's going to be NO2, nitrogen dioxide. All right, now to see if this is our molecular formula, we first have to calculate the mass of this empirical formula. So the molar mass of our empirical formula is just going to be nitrogen plus 2 oxygens. And if we calculate this through, this is going to be 46.01 grams per mole. So that's the mass of our empirical formula, NO2. To see if this one is the actual molecular formula, we have to compare the mass of the molecular formula given to us in the question with this mass. So essentially what we are doing is we want to find the molecular mass or the molar mass of our molecular formula and divide it by the molar mass of our empirical formula. Now, this molecular formula one is given in our question. It's found right over here, 92.02 grams per mole. So let's put that in there, 92.02 grams per mole. And we're going to divide it by the one that we just calculated, 46.01 grams per mole. So right away, I noticed they're not the same number. So this must not be the molecular formula. Grams per mole will cancel out in both of these, and we'll be left with a factor. And this factor, if we look at it, is going to be exactly 2. Perfect. So that means that we have to multiply the subscripts of our empirical formula. So I'm just going to rewrite that empirical formula here. I'm going to put the ones in just so that we can see what's happening. So N1O2. And now we're going to take this factor of 2 and multiply the subscripts by this 2. And we will get N2O4. And this right here is going to be our molecular formula. I hope that this was helpful for you. Please watch my other videos on empirical molecular formula and other stoichiometric calculations. There are some suggested videos that might help you a little bit more. Don't forget to like and subscribe, and thanks very much for watching. We will catch you on the next one.